Hello everyone, I am Harshavardhana and my teammates Akshara and Vaishnavi. We are joining virtually and here is a quick walkthrough of our hackathon project which is titled LLM Preference Aware System. It is nothing but a smart system that learns how the users uh, expects to have the responses and adapts over time using a dynamic graph knowledge. So let us now look at the summary of our project. So this system lets users ask questions, give feedback on the response, and have the model adapt in real time. For example, if you say write in bullets or explain in French, the model remembers and adjusts. It builds a live knowledge graph for each user, storing preferences across sessions, and only the latest preference is used for generating future answers. So going to the tech stack, this was built with Python using Streamlit for the front end, OpenAI GPT 3.5 Turbo as the LLM engine, and NetworkX plus MATLAB for managing and visualizing the knowledge graph. Preferences are stored with JSON and API keys are secretively handled with .NET, sorry, .env file. So going with respect to the creation process of this project, so we started by framing the problem. How can we make LLMs more responsive to user preferences? That actually led us to designing a feedback aware system where the model evolves with each interaction. So the code base was structured in a modular way with clear separation between the LLM interface, the feedback processing, the graph logic, and the visualization layer. For graphical design, we used NetworkX to model user preferences as edges from each user node to preference node. Each edge reflects the current state, which is nothing but active if it is marked in red or not. If it is not active, it will be marked as black. Then came prompt tuning. Only the most recent preference marked in red is included in the prompt. This sent to the LLM, ensuring it responds exactly as instructed. And to track this, I also built a thumbs up and thumbs down feedback loop. When users hit thumbs down, they can suggest improvements, which immediately regenerate a tailored response. To preserve preferences across sessions, I created a JSON persistence layer. Each user's graph is stored in separate file and reloaded when they return. Finally, I focused on UI polish using Streamlit app for better front-end interface. So coming back to the future work, we are actually planning to implement this in Neo4j database and also to handle hot deletes and also drop down kind of thing so that users can directly choose the preference from the drop down. And some key challenges include LLM responses with changing preferences, handling conflicting feedback, and managing multi-user persistence cleanly. A full demo of the working of our project is given in this below YouTube link and you can watch it. Thank you so much.